Hello, Mr. Ryan, right?
Yeah.
Okay, so look at this. This is the input. And this is the output. So can you guess what are the process? This is the input, this is the output. So from left to the right, what's the meaning of the output? Do you notice anything in common? It's
They have a 0 or 1.
Yes, that's good. Binary 0 and 1, right? The inputs, we have a binary string which contains only zeros and ones. And the output is, what do we get? By the way, this is empty string. So what are we looking for here? Anything?
But 1s and 0s, like, if they're just 1s or if they're just 0s. I'm talking about the other ones. I'm talking about 1, 1, 1.
Yeah.
They're all the same, which is 0. And the bottom one is 0, 0. And it's also 0. And 1 is just 0. So I feel like it's like, like, if it's just only like one, I don't know what you call it, like species, then it's 0.
Yes, okay, that's good. One species, that's 0. That's correct, but it's not everything. Okay, so how do you explain this one? Y is 4. How do you explain this one, which is 6? And also I can write another one, 1, 0, which is 0. 1, 0, 0, 0. 0, 1, 0, that's 2. Getting more interesting, right?
Wait, is it like a group and then...
Yes, a group, yes,
like,
you're right.
For example,
Yes, a
for
group.
example, there's like this part and is it like that?
Why is this 6?
Because the right one is 6.
Longest, right? Okay, so why this is 4? This is a group, right?
Yeah.
Why this is, oh, there's no group, okay? This is 2, right? Yeah, you're right. Perfect. If it's only one species, then you can't find a group, obviously. But this is not a group, right? 1, 1, 1, 0, 0, 0. This is not a group. A group is zeros and then ones, and the number of zeros equals to the number of ones. So we want to find out the longest group, longest balanced string, okay? So we define a longest balanced binary string as this. A number of 0 followed by a number of ones, and the number of zeros is the same as the number of ones. And we want to find out the
Yeah,
longest.
but if that's a group, then if it's an empty list, there's a zero amounts of zeros and 0 amounts of 1.
Yeah, so that's 0. Yes, you're right.
Yeah, but you said that to make a group, it needs the same amount of zeros.
Okay,
and
this
same
is the
amount of
special
ones.
case. Okay,
And
yeah,
then,
yeah.
And that's 0 amounts of zeros and 0 amounts of 1.
Technically, this is also okay, right? 0 number of zeros and 0 number of ones is still valid.
Yeah.
Okay, so let me give you an example, okay? 0, 1, 0, 1, 1, 0, 0, 0, 1, 1. What's the longest group? What's the longest?
I can't see.
What's the longest group?
Is it 4? Yeah, 4.
Why is it 4?
It's at the end. At the end in part.
Yeah, okay. Any more here? This is a group, this is a group. Yeah.
This is a group.
No, this is not group because 0 has to come before ones. Okay? Any idea how we solving this? How we solving
Use
this?
our big brain.
That's good. So who has got a big brain? So given a list, I mean, how do humans solve it? How do the humans
Just
solve it?
look at it.
We just look at it. How do you solve this? How do you solve this?
Bruteforce. Check every group.
Bruteforce, that's a good way. How do we Bruteforce?
Check every single group.
But there's no group. How do you Bruteforce?
Check every number.
Check every substring, right? Substring, what's a substring? Continuous, right? 0, 1, 0, 1, 0. This is substring. So basically you have 2 pointers which define the left and right. Left and right can collapse, meaning the same, right? So it's cn1 plus cn2, okay? N choice, there are n characters. I pick one. So substring, each one is a substring. 0, 1, 0, 1, 1, 0, 0, 1. Each individual character is a substring. Picking 2, what does it mean by picking 2? I pick a left position, I pick a right position, and then everything here is a substring, right? cn1 plus cn2. We can Bruteforce it. But obviously, do we need to check every substring?
No.
Do you notice what's this number? 640022. What's
Even
it?
numbers.
That's right. So it's even numbers. So the substring has to be even numbers, right? We can ignore the odd numbers, right? Make sense? 0, 1, 0. We don't need to check, right? Right? We don't need to check. We just have to check 0, 1 because 0, 1, 0, you know, it's not a group. Okay? So we can Bruteforce it. It's still square, and then for each one we need to check if they contains the number of equal ones and zeros, and zeros come before one, so time to next is O n cubic. Okay, but for this one we can have a better way. We can do this one pass. We can count from left to the right. We can count the number of ones and the number of zeros so far. Okay, so let's look at this example.
There's 5 ones there and 5 zeros there.
1 0 0 0 1 0 0 1 1 0 0 1. Okay? Yes? Okay? So now I'm going to.
4 times is 4.
Wait.
Near the middle part, near the
Okay,
end
so
of
now
the
this is the zeros, the number of zeros. This is the number of ones so far, okay? Continuous. Okay, so now I'm an index. This is index 0, okay? Index 0. How many zeros? Zeros. How many ones? 1, okay? Here. How many zeros?
1.
1. How many ones?
1.
No, 0. Continuous. Counting index backwards. Right? This is 0. We need to turn this 0. Okay? Here. How many zeros? 2. 2. How many ones? 0. Here. How many?
3.
3. And here? 0. Okay?
Mhm.
Here?
1. No, 0.
0. Yes. And then
1.
1. Okay? Here? 1.
1. 0.
2.
0.
Okay? 0 1 0 2, right? 1 0. Okay? We just go from left to the right and then count 0 and 1. Okay, so but what do we need this for? So can you get the answer here? In what cases we can calculate the length?
You need
of
to find the
okay.
word next to each other, the same thing like there's 1 2 and 1 2 here, and then next to each other. There.
Okay, so wait, which one is a group? This one is a group, right? This one is a group, right? So when we are here, what happened? We know now the number of ones, the number of zeros. So now we have 1 ones, right? We have 1 ones, and the previous one is zeros.
1 1 is not 0.
Okay, 1 1, okay?
So in the groups,
Yeah.
so there's 1 ones and then 3 zeros,
Yeah.
1 ones, 2 zeros, 2 zeros, and then 2 zeros and then 2 ones, and then 1 0. Like Ryan said, when they're like next to each other, you pick the smallest number, then you can group. You go from top to bottom, so you go from zeros to ones. The zeros, ones, you go the zeros first because it's for a group. You do the zeros first and then the ones. So you can do. So let's say go 1 2 3. That's a group of 3, and then 4 is just a group of 1. 1 is the smallest number, so you'll have a group of 1. And the other one is 5 to 6, which is 2, and then 7 to 8, which is 2. The smallest number is 2 which is basically the minimum number, so that's 2. So the group is 2. I don't think you get it. I'm in more detailed.
At this point, yeah, we want to know the previous 0, so we probably don't want to reset it to 0 immediately.
Yeah, but you can see that table. You make the table and you can see it. After you make the whole table,
Yeah.
then you can see it.
Yeah.
So all you need to do is start with zeros. So find a group of zeros, which there are 3 groups of zeros.
Mhm.
And so we try 1 2 3, which is a group of 3.
Mhm.
And then we're trying to find the next group of 1.
Yes.
So index 4, there's a group 1,
Mhm.
and then the smallest number is 1, so it's 1. So the group is 1. So there's another group of zeros, which is 5 and 6, which is a group, and then the next group of ones is at index 7 and 8, and the smallest number is 2. So yeah.
When we are counting ones, we want to know how many zeros previously, right? So at here, there's 1
Yeah,
zero.
you can see how much you make the table. You can see how much zeros it was that earlier.
Yeah. Okay. Yes.
Yeah.
Yeah, I know, but look, I need to modify something, right? When 1 turn into 0, right, we reset the zeros. But when 0 turn into 1, we don't reset the zeros. So when 0 turn into 1 here, right, this is 0, 1, 2, 3. Here we don't reset to 0. Here, right, 0, 1, 2, 3, 4, we don't reset to 0. We change it to 3. 1 turn into 0, we reset it to 1. 1, 2. Okay, and then now, here, this is 2. Right? And here, this is 2. Okay. Yeah? So, when 1 changes to 0, we reset 0. When 0 changes to 1, we keep the 0. Okay, basically. Why do we need it? Because when we are here, right?
You need to find if they're the same number next to each other.
So, yes, so here, look, I know there are 3 zeros and there are only 1 ones. So the...
But you don't necessarily need to have numbers which are
So look here,
the same.
let's look at this, 0, 0, 0, 1. 1, okay? So there are 3 zeros, right? 3 zeros, and there are 2 ones.
Yeah.
So what's the length of the maximum?
Yes, 2, because 2 is the smallest number, that's what I'm saying.
Yes, so if zeros is bigger or equal than 1, then we need to compare the 1s times 2, right? Yeah, this is the condition, right? Okay.
No, we go with the smallest.
Yes, 0 is bigger than 1 because zeros are always in the front, right?
Yeah.
If as long as it has enough zeros, right? As long as because look, just imagine if there are 100 zeros and there are only 5 ones. What's the length?
Yeah, but you
What's the length?
But you can do this, and
Yes.
yeah, and then the smallest number is 2 is 3.
No.
This is a group.
Yeah, this is the group. This is good, but this is a group, right? Because we are working from left to the right. We are here. We at this point there are 2 zeros, 2 ones, and the number of 0 is bigger or equal than the number of 1s. So we know we can make a group of 2 times 2. 2 is the number of 1s. When we are reaching this point, the number of 0 is 2. The number of 1s is 3. 2 is smaller than 3, so we can't make a group with this 1. Make sense?
But my point is, I'm trying to say that there's a group of zeros before a group of 1s, and then you choose the group is the one which is the smallest number of zeros or 1s.
It's a different way of looking at this, okay? So what I'm saying is that what I'm saying is that if the number of 1s is bigger than equal than number of zeros. No, it's the opposite. If number of zeros is bigger than equal than the number of 1s, so we can make a group of 1s times 2, right? Yes? If the number of zeros is bigger than equal or equal than number of 1s, we can make a group of 1s times 2, right? This is the condition we check, we updated the answer. So we go from left to the right and we update the number of zeros and the number of 1s. But we need to reset the number of zeros and the number of 1s. When to reset the number of 0? When 1 changes to 0. We don't reset the number of 1s when
the 0 turns to 0.
Yeah. When 1 turns into 0, we reset the zeros to 1. Okay? And then we reset the 1s to 0. Okay? Okay, let me write the code, okay? The longest balance string, okay? This is S. The current answer is 0. Zeros equal 0. 1s equal 0. Previous character is nothing at the beginning, okay? For I in S, if I is if it's 1, so we have a met 1, right? Look, we have met 1 here. Now we are meeting this 1. So what do? Meeting 1. So we need to 1s plus equal 1, right? If we have more zeros bigger or equal than 1s, then answer equals maximum of answer 1s times 2, right? Yeah, if we have more zeros than 1s, right? We have more zeros than 1, then the longest group is determined by number of 1s times 2. Okay? Then here, else, now here at this part we meet the I equal 0, right? Now we have 0. So what do we do when we meet a 0? When we are here? We are here.
When you're there, you
So obviously,
reset your ones.
1 equals 0, right?
Yeah.
But the zeros, we need to check the previous one, right? Because if this is the second 0, then we need to increment it. If this I is equal than the previous one, then zeros plus equal 1. Else, zeros equals 1, okay? And then the previous one equals I, okay? And then return answer. If previous is a 0, then we 0 plus equal 1, that was 0 equals 1, okay? So at this point, we set the 0 to 1. At this point, we set the 0 to 2. If we turn in this, yes? And then when it's 1 again, we don't set the zeros here, right? We compare if the number of 0 is bigger than the number of 1s, okay? Make sense here? Yeah? What's the time complexity?
Oh, Daddy.
If n is the number of characters in the function, obviously we're just doing 1, right? What's the base complexity? We have nothing, right? So it's all 1. Okay, so look, this is one, the previous one, right? We can use the enumerate here. So for ji in enumerate, what's the enumerate function?
It's
And then we don't need the
Is it
index. There's a j is the index. So
like
j.
listing like the index and value.
Yes. Ji. This is the index. This is the value. So we just have to check if else, then if previous equals 0, we can say if the j equals 0, if it's the first one or the sj minus 1, the previous character is 0. Okay, this is the same thing. Okay, so what have you learned today?
About finding these groups.
Yes. The number of zeros, it needs to be equals the number of ones, and then 0 needs to come before ones, right? So we talk about Bruteforce, but this is not very effective, right? Because we have to perform on cubic solution, on squares to find all the possible substrings which are of the even sizes, and then we need to perform an on to check if it satisfies this balance thing. Okay, and a better approach would be going from left to the right and counting the number of ones and then the number of zeros. If the number of zero is more than the number of ones or equal, right, then we know we can make a group of the number of ones times 2. Does it make sense? Yeah? Okay, that's it for today. Bye-bye. Bye.